Hi judges, we are Hack Tampa and we're here with 50 Shades of Gray Pills. The threats facing our forces today are becoming harder to identify. By diving deep into networks where adversaries interact, we can provide early detection, giving warfighters more opportunity to neutralize these unconventional threats. The sites on the deep web are more fluid than traditional social media. Our framework is extensible to allow easy expansion as new networks and data points come online. Our approach identifies the most important data elements, both obvious and obscure. It allows us to deeply analyze relationships using both surface and metadata. By applying rigorous heuristics and including feedback to reinforce key relationships, the data clearly shows trending topics before they become obvious to human analysts. To find meaningful relationships in the data, we used a scoring system like that used very successfully by Spam Assassin and coupled it with a feedback loop to reinforce strong results. By providing the feedback loop, we can better postulate whether potential candidate sets of relationships, accounts, or images are meaningful. The feedback mechanism helps to either confirm potential matches with additional evidence or could reduce the overall score for a candidate if it's a false positive. Understanding this context is a critical factor to our approach. Using the samples of data we programmatically obtained from the recommended data sources, Mastodon, ZeroNet, IPFS, and Steemit, Mastodon had the most accessible data, and we wrote a scraper using Python. ZeroNet required a browser simulation to spider the available content. Once you've traversed the pages, the nature of BitTorrent made it easily accessible with very nicely formatted JSON. Because it uses BitTorrent, we can grab every IP address from the swarm and geotag all the people that are participating in the swarm. We also identified a chat platform built on IPFS and were able to manually scrape data from that. These data points provided an important baseline to begin analysis. To augment the data, we applied both positive and negative points to help further refine the algorithm. We accessed the Twitter API to obtain pop culture trending signals. If we can find corresponding relationships with those identified on the primary sites, these could provide confirmation of the relationship. We also obtained a real-time list of IP addresses for Tor exit nodes. By correlating this data with the 4 primary sources, we could apply this as a known signal that elevated the scores for certain users. This allowed us to focus the network map on those users with the expectation that their social networks and connections would be of higher interest. We also obtained several lists for public VPN nodes that increased scores, albeit less dramatically than the Tor signal. Finally, we conducted 2 types of analysis on the image data that accompanied the social data. In addition to the obvious geo and EXIF data commonly available, we applied the Google Vision API and were able to infer significant data from the imagery. We used Python with this API to identify text data and language, URLs of similar images, search terms used to locate these images, and more. We also analyzed hash values for seemingly identical images to identify potentially hidden data embedded using steganographic techniques. We believe the tools we created in the last 24 hours provide a solid framework for a comprehensive analytical system. This starting framework will easily allow the introduction of new data sources, and the rule-based analysis allows the end user to tailor the results by seeding the algorithms with interesting search terms, persons of interest, and other relevant data points.